Okay, so functions. So when you have an equation, for example, y equals mx plus b, right? It's just a rule, isn't it? Isn't it just a rule?
Yeah.
So in that y, like for example, y equals mx plus b, what do you put into that equation?
You plug in your number.
For what variable?
M, B.
I mean x. Yeah, assume that m and b are already not just right.
Oh, the number.
You put in something for x, right, and you do stuff to it, and what comes out of it? The y value, right? So it's like a rule for y equals mx plus b. You put some numbers in for x, and the output is a y, right? Okay, so it's just input, do stuff to it, and there's an output, okay? So that's all a function is. It's just a special type of relation, okay? So it's a relation that converts an input. Generally it's x, right? But if we're using different variables, it might not be x. Has at most one output, okay? So not all relations are functions, okay? So this is important to know. Everybody paying attention? Got me? Okay. So functions are a relation where every input, every x value you put in, has exactly one output, y, okay? No more than one output. So if you put in an x value and do the stuff to it, so if you put in, like in y equals, whatever the function is, right? If you put in, and it would have to be different than that. Like say, put in a value of 3 for x, do stuff to it, and maybe out comes a 5. Okay? And then later on, you put in a value of 7 for x, right? Or no, we'll scratch that. If you put in a 3, maybe you get an output of 7 and 5. You get 2 outputs. Right? You can't have that. It's not a function. That's a relation, but it's not a function. Okay? If any input has more than one output, it is not a function. Okay? So we'll see what that means here in a second. Let's take a look at this exercise 1. Okay? So consider the function rule. Multiply the input, which we'd call an x, by what? 2, and then do what? And then subtract 1. Okay? So we're going to have a bunch of inputs here, x, 0, 1, 2, and 3. So what's the first thing we're going to do to it? Multiply by 2, and then, okay, so let's start with the 0. It's 2 times 0 minus 1.
0. Or negative 1.
So the input was 0 for this rule, and the output is y, negative 1. Okay? Let's keep going. 2 times 1 minus 1. 1. Input 1, output 1, right? So input, do stuff to it, and you get an output of y, okay?
3.
So 2 times 2 minus 1 is 4 minus 1 equals output of 3. Input of 3, 2 times 3 minus 1 equals 5. So we have a bunch of outputs here, okay? So now we can graph this, right? You know how to graph ordered pairs. X comma y. So your ordered pairs as you see them, aren't they input comma output?
Uh-huh.
Okay. So let's plot, oh, and by the way over here, see this x-axis?
Yeah.
We could consider that our input axis, right? We input some x value, and it goes up and down to somewhere on the y, which we would think of as the output. Let's plot these. Input of 0. So let's go to 0. What's the output? Negative 1. An input of 1. What was the output? 1. Input of 2. Output was what? 3. Input of 4. An output of 5. Okay? And we could draw. You guys might want straight edges. I don't know to do some. Let me know if you, like as we do this. You want a straight edge to make it nice and neat, okay? But we could make a line right through that. So that is a graphical representation. Uh-huh. Yeah. Well, here, does anybody want a ruler?
Yeah. Yeah. Actually, I think I have one.
And you want, hopefully maybe you got rulers at home. don't have to get nuts right now about this. And just find your way back, put them, any way out, put them back in the thing. Okay? So what this line means is that we can like input values in between our integer numbers there, right? And it'll still come out on that line. All right. So I actually did C, didn't I? Should have done B. So let's write an equation for this rule. So what would the equation be? The output would be Y, right? So let's call it Y equals, and we're doing stuff to X. What are we doing to X? So what do I write? 2x minus 1. So that's our rule. That's it. That's our function rule. You input a bunch of x's, and you output y's. Stuff goes in, stuff comes out. That's all there is to it. Okay? This is, in fact, yeah. It's not the only function, obviously. There's different ones, right? That's one of the simpler ones to work with. Okay. Yeah, and by the way, next, B is the starting. What's the B in this case? Notice how this starts at -1, the y-intercept, right? And the slope is up 2 over 1, isn't it? So it goes up 2 over 1, up 2 over 1.
X is the slope.
No, X, the number in front of X.
No, that's the slope.
Yeah, but whatever number's in front of it is, yeah. Okay, let's go to exercise 2. In the function rule from 1, what input would be needed to produce an output? What input, what X would be needed to produce an output Y of 17? So what are they asking us to do here?
Solve for Y.
Mhm.
Or solve for X.
Solve for X. That's all they're saying in a different way, right? Solve for the input that would have an output of 17. That's really what you're doing when you're solving an equation, right? So Y equals 2x minus 1, right? But it's actually 17, isn't it? Maybe I got to do it like this.
9. Oh, it's 9.
Yeah, okay, we know how to do this, right? So 2x equals 18. So an input of 9 will give us an output of what?
17.
17, right? Okay. Let's go to exercise 3. So it's a little different now. Function rule takes an input n and converts it to an output y by increasing 1/2 of the input by 10. So let's write an equation for this. Well, let's not write an equation. Let's do it this way. So what do we got? We're going to take an input. We're going to increase half of it. So we got to take half of the input and then do what to it? Add 10. And what is the input they want us to use? Okay, so let's do what they say to 50. Half of 50. And then what? Increase it by 10? What does that give you? What's half of 50? So we get 35. Okay? Well, let's write an equation for this then. What would it be? You'd output equal doing stuff to an input. Y equals, no, we're not using 50. 1/2 times any input x, it was 50 here, what? Plus 10. Okay? And there's our input-output rule, our function rule, our equation, right? All kind of the same thing, isn't it?
I just like the graph part of this.
All right. Now, we don't have to consider functions with numerical equations only, right? There's other data that can be presented as a function or not a function. Remember, for it to be a function, every input must have exactly how many outputs? One and no more. If any given input, any x you put in, generates more than one output y, is it a function? No. Okay? So let's look at this thing here. We got a rule that takes an input, the neighborhood child, and gives an output of okay. So this is any given kid here for the input, and what's the output?
First one.
Yeah, so this is the output.
This is not a function.
Well, let's find out. Why can we consider this rule? Why can we? Let me ask you a question.
Because
These are the
different.
do any of these inputs have more than one output with them?
Yeah.
No. They do. Which one?
Dang.
May's not an input. Do any of the inputs have more than one output? What are the inputs? Max, Evan, Zeke, Rosie, Nico. Those are the inputs. Do any of them have more than one birth month out here? Okay? And what? That's an output. But if you look at Nico, how many outputs does Nico have?
One.
If you look at input of Rosie, how many outputs does Rosie have? Zeke has one. Even though it's the same, right? These guys still have one output each. See what I mean? So we can call it a function because each input, in this case it's a child, right, has exactly one output. In this case, it's a month. Okay, so that rule is a function. So an output can show up more than one time, right? As long as they come from different inputs, right? Okay. Part B, what is the output when the input is Rosie? February. And it's F-E-B-R-U, kids. February. No, I just started getting pronounced wrong over the centuries. It's awkward. All right, find all inputs that give an output of May. What are the? Let's list off all the inputs that have an output of May. Okay, so Zeke and Nico. All right, what's the follow-up?
It's in the folders.
Why does this not violate the definition? We were just talking about that.
Because they have one output.
Right. Outputs can have multiple inputs, can't they?
Yeah.
Okay, so outputs can have multiple inputs. Multiple inputs, but not vice versa. Not vice versa. You know what that means, right? Not the other way around. Okay? It's Latin, by the way.
I thought it was vice versa. Visa versa.
Okay? We got that. Now let's move to exercise 5. Charlene heads out to school on foot on a fine spring. Why do they have to put that in there? Why can't it be a crappy or just a spring day or just one day? Does it matter? I think they're trying to get you interested. Does that make you interested more than
No. No, but they're trying to throw us off.
You know what it's called? It's called fluff. Anyway. Like in math and science, you get laughed at for just give me the basic facts. Anyway, her distance from school in blocks, right? Not miles or anything, is given as a function of time, right? So what would be the input here? If her distance in blocks is a function of time, what would you input to see what the output was? Time, like minutes, right? And what would the output be in? Yeah, blocks, a distance in blocks, right? So time would be the input. And blocks over here would be the output. So we're not using X and Y, right? Probably using T and B. Time, T, and where the X-axis would normally be. Okay? All right, let's look at part A. How far does Charlene start off from school? So what's her initial distance from the school?
20 blocks.
Well, let's careful. What are we counting on it by here?
0 blocks.
What's each one of these?
1.
2,
Oh.
4, right? You got to pay attention to that, right? So what is her initial distance from the school?
20 blocks.
No,
Or 22.
22 blocks, right? So she has 22 blocks to travel before she gets to school.
I just spelled block.
Okay. Part B, what is her distance from school after she's been walking for 4 minutes? So let's go on. We'll call this the t-axis. Okay, maybe we'll call this the d-axis for distance, right? Instead of x and y, it's more specific, yeah. Sure. Okay, so after 4 minutes, what do these count by on the t-axis? 1. So here's our 4. And what is her distance after 4 minutes of traveling? What's the output? 14, right? So the input was 4 and the output is 14. Right? Input of the t for time, output of the d for distance and blocks. Okay? After walking for 6 minutes, so it's like a new input. So let's go out here to 6. Here's 6. She stops to look for her subway, but how long does she stop for?
4 minutes. 3 minutes.
How can you tell?
It's from 6 to, and then she starts walking. Oh no, that's 3 minutes.
Right. So this means this part of the graph that's happening over time, remember, that's her distance. That part I just highlighted, is her distance changing over that time? No, it's horizontal, right? She's not getting any closer or any further away. And how long does she stay there?
She stopped for
3 minutes. Okay.
It just said that last one was the last one.
Yeah.
No, was that we should have followed
The group. All right, part D. Charlene then walks to a subway station before heading to school on the subway. Right? A local. What?
I thought she was walking.
She's walking, but now it's changed. She's walking to the subway.
Yes, but she should be walking to school. So she
Well,
walked what?
Be ready for conditions on the ground to change.
It's
Okay, before heading to school, how many blocks did she walk to the subway? So she was
Yeah, 2.
at 9 minutes. What was her distance?
2 hours. Why are you talking about minutes when we're talking about blocks?
Because the blocks happen as a function of minutes.
Alright, wouldn't that be 2 blocks?
Okay. So at 9 minutes, how far was she from the school? 9 minutes, how far?
As far as 8 or
10 blocks from the school. And then she walks to the subway. How far did she travel between minute 9 and minute 10?
2 blocks.
2 blocks away, right, from the school. But she traveled 2 blocks.
Was that walking or taking?
Well, we'll just read it. After she stands for 3 minutes, right, she then walks to the subway. So this is after standing for 3 minutes, right? Then she walks to the subway.
It takes her 4 minutes to get to school.
Is that at 10? That's at 11. I'm sorry, I just read it over here. That's at 11 minutes. Okay? So it took her 2 minutes to walk to the subway from when she was just standing there. Okay? All right, how long did it take for her to get to school once she got on the train? So that's from here. She gets on the train at 11 minutes, right? In?
4 minutes.
And it's all done in 15 total, right? So 4 minutes.
Honestly, I'm planning to go on this train.
Doesn't matter.
From her mom. They said it was a subway and now we're to a train.
Doesn't matter. Yeah, subway is a train.
No, it's not. It's a subway. It's a train.
Let's move on to the Regents' questions. Now, remember, listen, what's required for a relation to be a function?
only one output.
Every input has exactly one output. Now, read this first one.
All the
Now, listen, we haven't really done this. You see this F parentheses X? Have you seen this before?
yeah.
Okay, we're going to get to that later. It's in here, but that just replaces Y. G. It's called F of X, G of X, H of X. In other words, F as a function of X. It's another way to write. We'll get into that. Just replaces Y. So take a look at this. Remember the rule that makes things a function and say which one of those would represent a function. Every input is exactly one output. Choice 2, she says.
I hate these. What one is not a function? What one is?
Well, let's take a look at choice 1.
Wait, what's a function again? Can you explain it?
It's
It's a relation where every input, X, has only exactly one output.
So the input.
This will clear it up, I think. Take a look at the inputs in this one, 1, 2, 3, and 4. Or 1, 2, 3, and 2. Okay? Now notice that 2 here has an output of 2, and 2 again, later on, has an output of 6.
So there can only
So that's
be
not
one
a function.
number. The numbers can't repeat.
This input of 2, that's, so be careful there, right? Because you saw in the other one, they can repeat over here as
They
long as
can't
it's a
repeat in
different,
the X column.
yeah.
Oh,
Now,
so-
also, yeah.
So in the X, you can't have two, like say two, you can't have two of two.
More than once.
Yeah. But you can have it in the,
That's true, but I'll show you an exception. What if this just said, what if that said 2 and 2, and then this one said 2 and then 2?
No.
So that's still a function. It's the same, it still has one output, right? 2 has an output of 2, has an output of 2. It's still a function, because that's still one output if it was like that. So you're kind of right with what you said, except if you see something goofy like that. Like, why would somebody write it twice, right? But that's possible, okay? So this one, let's look over here. Are there any inputs here that have more than one output? It's the same thing again, right? There and there. What about in the last one?
3.
Input of 3, an output of 2, and a separate output of 6. So this one's fine, okay? I think you might see some, that's why I want to, like, where you have something like this, and they'll show you the input twice, but maybe with the same output, so they do it to trick you
Why
sometimes.
can't you get an input twice though?
But, I thought I just,
You can't use it twice? Like, I don't understand that.
there's an input of 2. What's its output?
Oh, because then it wouldn't be correct.
Then it has 2 outputs, 2 different, separate, distinct outputs. And so it's not a function. Okay? All right, let's try this again with choice 2. Which table represents a function? Let's look that over.
I don't know what one.
it's one.
No, it's not because there's two twos.
Oh, so yeah, it's-
I feel like it's two. This is confusing. They're
Well, look at the inputs. How many inputs or how many outputs does 1 have in choice 2?
4.
That's not exactly 1, is it? Right?
It can't be 3.
They're all wrong.
Negative 3.
What about, no.
No,
They
that
all
one's
have
negative
double
3.
threes.
I wonder. They do, don't they?
Yeah.
They messed that up.
I have to go back. I wonder if they have, like, because I pulled it from one of the exams. I wonder if the exam this comes from had like a note that came later about accepting any answer or disregarding this one. That, something's wrong
Can we
with that.
change that to?
Yeah, let's just double check. So 2 and negative 3, 2 and 1, not a function, right? Obviously not a function, right?
They're all negative 3.
Negative 3, 0 and negative 3, 2.
And this would be negative 3.
Again. Oh, you know what this is? Okay.
Now to
I know what happened. I think this was supposed to be a different looking choice.
A regular 3 instead.
I think that's what that is. Okay. On to number 3. So we have some different looks now. Different looks here now.
Wait, can we circle number 3 for that one?
Just right now disregard it because I have to fix it for the next question. Which one of these, is there a key word in this question, kids?
Is not.
Not a function.
So number 4.
I think number 3. I don't know why.
Well, number 4.
It's either 1, 2,
2
or
has 2
4.
different outputs.
Yeah, but also 3 doesn't work.
3. Okay, let's think about number 3 because we're going to get to the graphical version of this, right? Remember, the X is all your inputs, right? Right?
Yeah.
So like if I input an X of 1, I get an output, it looks like 0, right?
Yeah.
If I input an X of 5, I get an output of 4, right? Okay? But do any of these inputs on this input axis have more than one output?
No, because the outputs repeat, or the outputs turn negative. So they wouldn't be repeating.
Well, the inputs come down here, yeah, right. The inputs become negative to get the same output. So that's a function. Right?
Because it goes negative.
Oh, so it doesn't matter if it's negative, like say if you have 3 and then you have a negative?
It doesn't, it's just, yeah, it's just strictly, each input needs exactly one output. Every input I pick along here, any number I pick on this axis, if you go up or down to the output, or down in this case, right, there's only one of them.
I'm saying, like, say if I had positive 3 and then a negative 3.
For an input,
For, yeah,
X,
yeah.
okay, positive 3, right there, and a negative 3.
But that's your function?
Yeah, because, what, just take positive 3. How many outputs does it have? Just one. How many outputs does negative 3? Okay, this goes back to negative 3 is a different number than 3. Maybe that's a confusion. Because I know a lot of times you kids will say just 3 when it's supposed to be negative 3, thinking it's the same.
They can't.
They are different numbers, right? So, and they each have one output.
Like they're both.
Let me show you one. What about this? Is that a function?
Yeah.
Wait a minute. This input has that output and that output. That input has 2 separate outputs. So is that a function?
What?
Does it make sense? You see that? Okay. All right. Well, anyway, what was our choice here?
4.
What? Input of 2, clearly. 2 outputs. Not a function. Right? All right. Let's flip over.
I look like a homework, I'm already confused about it.
4 relations are shown below. This looks like what's called a step function here in this first one. State which relations are functions. Got 1, 2, 3, and 4. Now you guys know what the open and closed circles mean, right?
Yeah, but this
Open
one-
means not included, closed means included. So that's kind of key.
I think it's number 3. If that is number 3.
There might be more than one. One,
Alright,
two.
number 3 is definite.
Well, let's look at 3.
It doesn't-
Input of negative 4, 0, 4, 6. So there's nothing repeated in the input. So there's no way, right? So 3 definitely.
Leave me alone.
Any others?
One.
Well, let's see. Let's look at some inputs. Here's our input axis. Let's input x of 1. How many outputs does it have? 1, 1, right? Now, wait a minute. You think this input of 1, 2, 3, 4 has 1, 2. But wait a minute. What's that open circle mean? Not included. Right? So how many inputs does this have?
1, but
Just that one.
But 1 would still not be it because the
But-
other one.
Okay, let's go out to 1, 2, 3, 4, 6. Now you got,
2.
that means that's included, closed, and it also has, so 2, right?
It's 3.
So because of this, it can't be that one. Let's look at 3.
That's not a function because the 2's repeat.
What's the input here?
1.
What's the input here?
2.
You get the idea? So I got a 1 with a 2, 2 with a 3, 3, 8. Oh, wait a minute. Here's a 2 with a 5, and a 2 outputting, well, it's the same as 5, negative 5, isn't it?
No.
Okay, thank you. So that's not a function.
But it still has 1 and negative 2, and that is.
And that's also violates it too, right?
Hold on.
What about y equals x squared? Think about what you can put in for the x. How many answers do you get when you put an x in here and square it? Just one. Whatever x you put in, you get one result. So is this a function?
Yeah.
We just said every input X you put in, you only get one result output. So that's a function.
So 3 and
So 3 and 4.
4.
So 3 and 4, IV.
These numbers are more confusing than math.
Explain why the other relations are not functions. Well, that's pretty simple.
The 1 repeats and the 2
Okay.
repeats.
They have, let's just say they have multiple outputs for a single input. How about that? They have multiple outputs for a single input. Okay. And we got one more to go. This will be pretty simple. So in 5, they're defining function as just a set of ordered pairs. Okay? 0, 1, 2, 3, 5, 8, 7, 2.
It's 4.
Isaac is asked to create one more ordered pair for the function, to keep it a function. Okay? So probably easiest to check your inputs, 0, 2, 5, and 7. So we probably don't want to add another one that's got the same input, right?
Yeah, so it's 4 because it's 1.
Okay, here's a 0, there's a 5, there's a 7. Well, there's a 1. I don't have an input of 1, so that won't cause it to not be a function. Does that make sense? Okay?
Easy.
Good, glad it's easy.
Well, I did
Right.
this last year, so.